class is 18 and above only.
I'm like 20 years old. It's okay.
We'll try to keep it PG. All right.
Let's start off with some 9/11 jokes.
That's right. I had to fill out my. We're live. So I had to fill out my Secret Santa thing the other day, and they want to know what your favorite holiday was, and I was tempted. So it's the most none of your business. So I think I might have left that one blank, honestly. So here's what we're gonna do. We're gonna do reflections. Now, the first third of this we did last week. You are correct in thinking that. Someone pointed this out. What we did last week was this. I gave you a point, and then I gave you an equation, right? And you would graph that equation at some line, and then I'd say find the line that's perpendicular to that, or parallel, right? We did parallel through that point. We'd find the equation for it. Or we'd say do perpendicular, find the equation and graph it, right? That means it's going to hit it at 90 degrees. What we're doing this week is we're adding on a couple extra steps. After we do that, we're going to find where they intersect, and that's going to be our midpoint. And then we're going to use midpoint formula to flip this point across there so it's the same distance on both sides. So we take A to A prime. So the first half-ish of that we've already done before, and you guys did pretty well in the quiz last week, right? Most of you did at least. The second half is what's going to be a little tricky. First couple examples here, we're going to have them be nice examples, meaning that all the answers will be integers. And then after we get that under our belts, we're going to switch to some more medium and hard examples, which means the answers will be rational numbers. So, am I? Yeah? Yeah, I know. We're getting rid of this stuff down here. I know I'm cheating. Yeah, I know I'm cheating, but you know what? Whatever. Who's going to stop me? You?
Yep.
Yeah. Like to see you try. All right.
I'm leaving if you do that. Said, are you still in?
Enough.
Wait, what's the date today?
We're halfway there, boys. All right, so here we go. Y equals 2x minus 2. That's the line of reflection, the LOR. Oh, you cannot see it.
I hate to break it to you, but I lost 3 days ago.
All right, enough. I don't want to hear about you shaving your beard, okay? So, I know. So here's your line of reflection. And here's the original point. The original point, enough, is going to be negative 4, 5. Let's graph that. So make your coordinate plane now. Right? Negative 4, 5 is the point we are graphing. So that's going to be here. Negative 1, 2, 3, 4, and then up 5. 1, 2, 3, 4, 5. And that's point A. I'm going to graph our line of reflection, which is in slope-intercept form, which is convenient, because then we know that our intercept is negative 2, meaning the y-intercept. And then we have a slope of up 2 over 1. And down 2, back 1. If we take out Saddam, draw our line. This is our line of reflection. I'm going to zoom in. How are we feeling about that so far? If this was the quiz, that's it. Would you feel great? Awesome. Okay. Plot the point, graph the line. How do we feel about graphing a line in slope-intercept form? How do we feel about that? Great. Thank you.
Horrendous.
I used to do this. Why don't I do this anymore?
Yeah.
How do you feel so far?
How's this? My opinions don't matter. Mr. Mac.
Yeah, you know what he's gonna do?
You feel like you got this or no?
Like, what's this?
Yeah, so far.
Yeah.
Yeah. Negative 2.
What's this?
Up 2 over 1. Yeah. Okay, cool. Yeah. Yeah.
Yeah. Okay.
Yeah. Okay. So, now what we need to do is what we were doing last week. We want to find a line that is perpendicular to the blue line, meaning it hits it at 90, and goes through point A. So I'm looking for a line that's perpendicular. So what is my slope going to be if I want a line that's perpendicular?
Flip in the gate.
Flip in the gate, what's the slope going to be?
2, 1, 2. 1, 2, 1,
Negative half.
1, 1.
Negative and half. We don't know what B is yet because we have to plug in our point to see what that's going to be. Again, the equation of a line
Big brain.
is telling you the relationship between x and y. Right? A line itself contains all of the points that make this statement true. So, for instance, 1, 0. If you plug in 1, what do you get for y? If you plug in 1 right here, what do you get for y? Oh, come on. 0, because 2 times 1 is 2, minus 2 is 0, right? So 1, 0 is the solution. Every point on this line is a solution to this equation, right? An x value that you plug in and it pops out a y value. What we're trying to do is figure out where these two lines, the blue and the red that we're going to graph, where they agree, where they both have similar solutions, meaning that when you plug in a number for x here and that same number here, you get the same answers for y. That's going to be where they intersect. We're going to get to that in a second. So what we want now is we want to put A on this line. So we want negative 4 and 5 to pop out. So negative 4 goes for x, 5 should pop out for y. That's what we want, so it goes through that point. Meaning we have to figure out what B has to be in order for us to get that, right? So if we plug in negative 4 here, what does B have to be to make this all equal 5? So we're going to plug in negative 4 and 5. When we do that, we get this. Where's my red pen? I know.
What's the song today?
We don't have one today. I know.
We've had a song today. Like
What is a negative times a negative? That's because we have a lot of days off. When we have short weeks, we don't have them. Negative and negative. Makes it positive. Half of 4 is what we're doing here, so that's 2. Remember, of is multiplication, half of 4. If you don't like that, you can multiply by the top, then divide by the bottom. Or you can divide by the bottom, get 2, and then multiply by the top, still get 2, right? Subtract 2, and we find out that B has to be 3. So in order for negative 4 to pop out 5, B has to be 3, which means our equation, Danny, knock it off, has to be negative a half x plus 3. We're going to pause for station identification. How do you feel about this bit now?
Easy.
Plugging in our coordinate, negative 4, 5. Doing math. Again, the doing math part might be a little tricky, but you see the idea. Plug it in, get your new equation. Solve for B. Now we're going to graph that. So that's plus 3 for the y-intercept. 1, 2, 3. And our slope is down 1 over 2. And look, it does go through A. And there is our line that A is going to end up on, right? Or A prime, I should say, is going to end up on. Awesome. So, enough. So A is on that line. A prime is also going to be somewhere on that line as well. Cool? So far, so good?
Yes.
Awesome. All right, so now what we're going to do is we're going to figure out where these two lines intersect. And for this problem, you can eyeball it and figure out what that intersection is. But we're not going to do that. We're going to do the math behind it because eventually we're going to not be able to eyeball it. So we need to practice without doing that, right? So that's going to be our midpoint. And the idea, again, is that we're going to take this distance right here using midpoint formula and flip A to A prime using the midpoint formula. First, we've got to figure out where these two lines intersect. So again, a line is a collection of all the points that make this statement true, right? If you plug in any of the points on here, you'll get a true statement. Same thing for the red line. Any point on here, like negative 4, 5, if you plug in negative 4 here, 5 should pop out here. What we're asking is where do they agree? Meaning that when we plug in 2 for x, both of these should have a 2 come out for y. If I plug in 2 here, I get 4 minus 2, which is 2. If I plug in 2 here, I get negative half times 2, which is negative 1, plus 3 is 2. So 2, 2 is where they're going to agree. How do we figure that out if we aren't able to just eyeball it? Yeah.
Set the two equal to each other.
Exactly. So what we're looking at is where they agree, meaning that these y's are the same. And if those y's are the same, if y equals 2x minus 2, and y also equals this, shouldn't they equal each other? Right? That's the idea. So now to figure out where they intersect, if you can't eyeball it, we're going to set these equal to each other. So 2x minus 2 equals negative a half x plus 3. We're trying to find out where they intersect. Where they intersect is a coordinate. So we're going to get an x and a y, right? So first we're going to get the x using this. We have one variable for one equation. We're going to do a little bit of math. So here's what we have. I'm going to add 2 to this side. So moving that over, I get a 5, right? And I'm going to add a half x over to here. And I'll write that out just so you can see what I'm doing. So I moved a half x over by addition. And I moved the 2 over by addition, which combines with the 3 to make a 5. Everybody good so far? Okay. Now we're going to get our x's together. Terrible idea in math. Or real life, great idea in math. Man, I am just losing it today. We need to ask ourselves how we get common denominators. In other words, how many halves are in the number 2? How many halves are in the number 2? 4, right? And you can check that. When you write that down, 4 halves. Well, fractions are just division for lazy people. So 4 halves is really 4 divided by 2. Is 4 divided by 2 the same thing as 2? Yeah. So we didn't change the problem. We just made it look different. We got a new perspective, which now allows us to see how many halves we have total. If I've got 4 halves and you've got 1 half, how many halves do we have? 5 halves. 5 halves. All right. How do we separate the 5 halves from the x? Division, but we don't divide fractions. We multiply by their reciprocal, right? Now, if you're a multiply by the reciprocal person, great. You're going to multiply by 2 and divide by 5, right? If you're not that type of person, watch here. I'm going to break that up into 2 steps. If this was 5x, what would you do to get rid of the 5? Divide by 5, right? If this was x divided by 2, what would you do to get rid of divide by 2? Multiply by 2. Well, that is what it is. It's just both of those at the same time. So you want to get rid of the division first or the 5 first? The 5? All right. If we divide everything by 5, what's 5 halves divided by 5? 1 half. What's 5 divided by 5? 1. Okay.
Why would you do that first?
Coda said he wanted to. How do we get rid of the divides by 2? Because that's really what this is. Timesing by half is the same thing as dividing by 2. How do we get rid of divides by 2?
What?
How do we get rid of divides by 2? Times 2. So half times 2 is 1. 1 times 2 is 2. Maybe you didn't like that. All right, Coda said divide by 5 first. Maybe you'd rather times by 2 first. Well, if we times by 2 first, we get 5x here equals 10, right? Because we get rid of the divides by 2. Now we divide by 5, x equals 2. Cool? So where they intersect is at 2 comma something. We found x, it's 2. How do we find y? Yeah. Mm-hmm. So remember, it doesn't matter which equation we plug it into because both of them, when you plug in 2, should have the same number pop out. That's why they intersect there. So would you rather plug it in the top equation or the bottom equation? Top equation. Let's plug in 2. What's 2 times 2? Subtract 2. 2. So they intersect at 2, 2. That's the intersection point.
That's big brain.
Okay? That's our midpoint. How do we feel about setting them equal and solving for x? Common denominator is still a little weird, but other than that, we feel decent. Setting them equal, solve for x. After you get x, plug it back in, get y. In this case, they happen to be the same. Okay, next thing we're going to do is now that we know what our midpoint is, it's 2, 2, and we know what a is because they gave it to us, we can use midpoint formula to find out where a prime is going to be. So let's talk midpoint formula. First off, what is midpoint formula?
X is over 2, and Y is over 2.
Something like that? Give me a better explanation. Average of the x's, average of the y's. When we average stuff, do we add or subtract? We add them up. So we're going to add up our two x's for our 2 points. We're going to add up our 2 y's. But then when we average, after we add them up, what do? Divide by the number of pieces, which is 2 in this case, right? That's midpoint formula.
C.
So we know our midpoint. Our midpoint is 2, 2. That's what we just found. We know A, because that was given to us. What was A in the beginning? What was A? -4, 5. Whenever you plug stuff in, wrap it in parentheses. Plug it in for x1 and y1. Again, these 2 points right here, x and y, that's going to be the coordinate of A, the point they gave us in the beginning, this guy. Everybody cool with that? Now we do not know what x2 and y2 are going to be, because that's going to be our coordinates for A prime. So x and y is going to be A prime, the thing we're looking for, right? The flip. Everybody cool with that?
Yeah.
Decker, you with me?
Yes.
Wonderful. Xavier,
Yes.
how are we doing?
I'm working on 5 hours of sleep
Horrendous.
right now, and I'm
Okay.
honestly doing pretty good.
So Xavier, I asked earlier if we were good with this stuff. Were you good with that stuff?
No, I literally said horrendous and you ignored me.
You said horrendous during that time? We'll have to go back to the tape. Xavier, where did I lose you? Graphing the blue line. Good?
No, that's the part I didn't understand.
This part.
No, right underneath it.
Okay, so finding the red line.
Yes.
Okay, we flipped and negated the slope to make it perpendicular. Right? Because we want perpendicular. Hit it at 90 degrees. Is that cool?
Yeah.
Flip and change the sign. Right? So 2 is 2 over 1. We flip it. We change the sign. -1/2. Then to find out what B has to be, we plug in our point because we want this to be perpendicular and go through this point, right? So I plug in the point, -4, 5. I do math and I get, hey, look, B has to be 3. There it is, so I write it down. Cool? I graph that line. 3 for the y-intercept. Down 1 over 2 for our slope. I draw the line. So far, so good. Awesome. Now I want to know where those lines intersect because I need to find that midpoint. Because the distance between A and the line of reflection should be the same between the line of the reflection and our reflected point. Okay? Right? Me in the mirror, it's going to be the same distance from me. Right? Cool. Okay. So, where do they intersect? Well, we can eyeball it here, but a lot of the time we won't be able to. So what we have to do algebraically is set those two equations equal to each other, the blue and the red. Y equals this. Sorry, y equals this, right? And y equals that. So they should equal each other by substitution. So here we are. Good? Now I solve for x. I do math. I found out x is 2. Trust me on the do math part, okay? After I get that x is 2, I need to look for y, right? Because we have a coordinate here that we're looking for. The intersection is a coordinate, right? So I found 2. So I plug 2 back into either equation. We chose to plug it into this one because it's easy. When I plug 2 in, I get 4 minus 2, which is 2. So this is a coincidence. They're both 2. That's the intersection point. We good now? Awesome. Now, my midpoint was 2, 2. A was -4, 5. I'm looking for where A prime is going to be. That's what x and y are. Are we cool now?
Yes.
Awesome. Average of the x's, average of the y's? Wonderful. All right, so now let's solve. We know that this is a coordinate equaling a coordinate. That's why we have the parentheses here. So we know that this part right here should equal this part over here, right? The x's should equal each other. Same thing with the y's. The y part here should equal the y part there. So let's write that. We know that 2 should equal x plus -4. What's an easier way to write plus -4? -4. So we have x minus 4 over 2. How do you solve a problem like Maria? We want to get x on its own. Alex, what's up? What's up? Gotcha. So where did I lose you? since the beginning?
Yeah.
So I went over it with Xavier. Graphing the line. We good with that?
I just want to know what you think.
Are we good with finding perpendicular slope? -1/2. 2 over 1, flipped, negated, -1/2. Okay. Then we plugged in our point, -4 and 5. We did math and we got b was 3. Cool with that? Okay. Then I set those two equations equal to each other. That way I could figure out where they intersect. I set them equal to each other, I did math and I got 2. Trust me on the did math part. After I got 2, I plugged it back in to figure out what y would be. When I plug in 2 here, it turns out I get 2 for y as well. Then, that was my midpoint, 2, 2. We just found it. And I know my original point was -4, 5. That was a, that they gave us in the beginning. And now I'm looking for where a prime would be. The reason I'm doing midpoint formula, everybody, is that I know the distance between my original point and the line of reflection, the midpoint, should be the same on both sides, right? Reflected me is the same distance from the mirror as I am from the mirror. A is the same distance from the mirror as a prime will be from the mirror. So I'm using midpoint formula to find the missing endpoint. That's this guy. Better? I know that this part of the coordinate should equal this part of the coordinate. So I wrote that. 2 should equal this. Plus minus 4 is the same thing as just subtracting 4. Cool? So now we're going to solve this. We're going to get x on its own. How do I get rid of divides by 2? Multiply. So I get 4. Add 4.
Oh, no. Oh, yeah,
X is 8. So x is 8. Meaning that a prime has 8 for its x value. Cool. And that makes sense. If you look back at our graph, 8 to the right, yeah, that looks like it should be 8 to the right, right? Somewhere over here. The question is how far down now. So now we're going to find the y. These two parts equal each other. So I'm going to write that. 2 equals y plus 5 over 2. I'm going to get rid of that division by multiplying. What happens when I multiply both sides by 2? We get this. And what do I get on the left side? 4. Now I subtract 5. There's a prime. And now we graph it. How do we feel about this part? Xavier.
Yes.
These two equal each other, do math. These two equal each other, do math.
Correct.
There's a prime, the missing endpoint.
Oh, it's got
8. 1, 2, 3, 4, 5, 6, 7, 8. Down 1. A prime. That's the reflection. A reflected to A prime. Yeah. Because you could just eyeball it. Mm-hmm. See, first hour I put. So first hour I put through hell because what I did is I didn't give them these nice ones. I had them make up their own line of reflection and give me their own point. Because 99% of the time it's not going to be eyeballable. They're going to intersect at a weird coordinate and you're going to be screwed. So yes, show all this work. Because here's what happens, right? Every year, somebody thinks, I'll just eyeball it. It'll be great. And they get some of them right, because you can't eyeball some of them, right? I'll give you some nice ones. But then the ones you can't, you try to eyeball it because it looks like, oh, yeah, sure, why not, right? And then I have to give you no points for the problem because you completely screwed it up and you didn't show any work. If you make a mistake here and say, oh, -1/2 times -4 is 7, I go, ha, you're a dork. And I take up 1/2 point. But if you do this and go, oh, yeah, that's right, then you're screwed, right? Hi.
How are you doing? So would you give us the line of reflection?
Yes. So the problem will be this. I'll give you the line of reflection, and I'll give you the point. You'll plot the point, you'll do the line of reflection, the rest will be on you.
That's pretty easy.
It can be. So here's what we did. I graphed the blue line, -2 for the y-intercept, up 2 over 1 for the slope. Then I found out my perpendicular slope. Flip and change the sign, right? Then I plugged in my point, got B, graphed it. 3 for the y-intercept, down 1/2 for the slope. I set the two equations equal. I solved and got x. I took x and I plugged it in and I got y. That's where they intersect. That point right there. I use that midpoint and my original point to find the missing point, the point that I'm looking for, the reflection, right? I do math, I got this. Again, the do math part, I know you're like, ugh, right? But I don't care about that, okay? I want you to feel comfortable in the concept here. Graph your line of reflection, find your perpendicular, see where they intersect, flip the point using midpoint. Now I don't want you to write anything. So we're going to do another one together, and you're going to watch the show. Okay? Here we go. Here's the show.
I don't like watching shows too much.
You have to. Line of reflection. This is what's given to you in the beginning. Thank you. This is what's given to you, the line of reflection, and they give you the point. Don't write this down. Put your pens down.
It's not a pen.
Put your pencil down.
I'm gonna write it anyways.
Don't do it. You'll learn less. Seriously.
I was already learning nothing.
You will. Yeah, but you're going to learn more doing it this way. And they give you A. And for this problem, they're going to say that A is negative 8, 1.
Alex, they ready?
So here's my graph. Negative 8, 1 is here. 1, 2, 3, 4, 5, 6, 7, 8. Up 1. There's A. And our line of reflection is going to be this. Negative 1 of my y-intercept. Up 3/5 is my slope. 1, 2, 3, 1, 2, 3, 4, 5. I'm going to draw my line.
Wait, why are we supposed to be ready?
Don't do it. There's the line of reflection.
Pretty good.
So, questions so far. How do you feel? If you're going to be stupid, be funny. Bottle. All right.
Water in there.
Yeah, I know. Sit down until I'm done. Sit down. You're being obnoxious and everybody's losing track of what's going on. Okay? So, I know. But think of it like your phone, putting it in the caddy. I have a water bottle caddy. That's it. Okay? You can get it back at the end of class, okay? Have your parents come pick it up. So here we are. Line of reflection. A. How do we feel so far?
Easy.
I was paying attention.
Can we graph the line?
Yes.
Down 1, up 3/5.
Yeah.
Xavier, do you have glasses? Do you have contacts?
Yes.
Do you have them on?
Yes.
No, you don't. Sit up here.
I do have.
For real.
No.
And you can see?
No,
Yes.
Good.
it's not.
Down 1 is our y-intercept. Up 3/5 is our slope. There's the line. We good? Look up here and put your phone away.
Gucci.
Are we good now?
Yes.
Okay, cool. So now what we need to do is we need to find the line that's perpendicular to this one that goes through this point. Now, all of you guys are really tempted to draw a line like this, I bet. Right? And you'd be wrong, because that's not 90 degrees, right? So now you're going to BS your way. No, we're going to do math, okay? So here's the line that's perpendicular to that. It's going to be y equals, flip and negate the slope. When I flip the slope, what do I get? 5/3, and then I change the sign, it's negative. I don't know the b yet. I need to figure out what b has to be so that when I plug in negative 8 for x, I get 1 for y. So I'm going to plug those in. 1 for y. Negative 8 for x. Then I do math.
Can I write this down? Yeah.
No. Negative times negative is a positive. 5 times 8 is 40. So I get 40/3 plus b equals 1. So now I'm going to subtract 40/3. It's a little gross, but it's going to be fine. We need common denominators. How many thirds are in 1? 3. So we have 3/3 minus 40/3. And you can check that. Is 3 divided by 3 still 1? Then we didn't change the problem. We just made it look different. Totally legal. 3 minus 40, negative 37 over 3. Ugh, gross. That's what this line of reflection is. It's y equals negative 5/3 x minus 37 over 3. Disgusting. Okay, so what we're going to do is we're going to estimate. We're going to use our slope here. We're going to go to this point, and here's how we're going to graph it. We're going to go down 5, 1, 2, 3, 4, 5 over 3, 1, 2, 3, right here. I'm going to draw our perpendicular. Now, if you tried to graph it the typical way, go down 37/3, right? Good God, right? Be smart. You already have a point. Use your slope. Find another nice point. Got it? Good. That's why we're watching. So, this is A. Now, I wonder where they intersect. You can eyeball it this time, but we're not going to, right? So here's what we're going to do. How to figure out where the lines intersect. We're going to set the blue equation equal to the red equation, and where they equal each other is where they intersect, okay? So here we go. 3/5 x minus 1 equals negative 5/3 x minus 37 over 3. Ugh. But it's okay. It's going to be gross, but it's going to be fine. We set them equal, then we do math and get x, right? After we get x, we plug it back in and we get y. That's what's going to happen. So just watch the magic, okay? We're going to add one, we're going to add one to this side. So I get this. Let me do it in a pen so we can do this a little bit faster. When I add 1 to this side, that's 3/3, right? 3/3 and 1. So I'm left with negative 34 thirds. Negative 5/3. I'm going to add 5/3 x to this side. Need common denominators, so I'm going to make this a 15. How did I make that 5 a 15? I multiply by 3. So I multiply by the top by 3. 9 over 15 reduces to 3/5. I didn't change it. I just made it look different, right? Here, I need a 15 in the bottom, so they're common, right? What did I do to the 3 to make it a 15? Times by 5. Times the top by 5, I get 25. 25 over 15 reduces to 5 over 3. I didn't change it. I just made it look different. How many 15ths do I have? 9 plus 25. 34 15ths. Here we go. We can either times by 15 or divide by 34 first. Which would you rather do? Let's divide by 34. I get this. What's negative 34 divided by 34? All right. Let's times by 15 now to get rid of the divides by 15. I get 1x, right? Does that reduce?
No.
What's negative 15 divided by 3?
Oh, I thought he said, is that reduced? I didn't know he said, does that reduce?
All right.
And that's only x.
Shut up. Math. Ugh. But do we get that we set them equal and then we get our answer?
See?
Awesome. All I need to know is, can you set them equal and find the answer? Do you see the idea there? I don't care about this. That's why I'm doing it and you're not. Yes. Which 34? This one? If I add 1, that's 3/3, right? So when I add 3/3, I get negative 34 thirds. Right? Follow me? Okay, cool. So we get negative 5. What I need you to know is what you do after you get the negative 5. What do you do? Yeah. Exactly, right? Which equation would you rather plug it into? The top, oops, sorry, can't see. The top equation, we're plugging in negative 5, or the bottom equation? The top, hands down, right? We plug this one in. So I've got negative 5 plugged in here. Follow with me. Negative 5 divided by 5 is? Negative 1 times by the top. Negative 3, subtract 1. Negative 4. So y is negative 4. This is our midpoint. I'll do that again. I plugged in negative 5. Negative 5 divided by 5. Negative 1 times by the top. Negative 3, subtract. Negative 4. So that's our midpoint. Nancy? Doing okay? All right. So now we're going to take this point and plug it in the midpoint formula. Alex, what is the midpoint formula? See, you wouldn't have to guess if you understand the concept. Someone tell them how to think about it. Yeah. Nope. How to think about it, Katie. Average of the x's, average of the y's. When you average your bats all together, right, you're adding them all up. And then you divide by the number of at-bats, right? So we're adding up all our x's and dividing by the number of x's, too. So that's midpoint formula. Average. We add up, divide by the number of pieces. Okay? We know our midpoint. We found out it was negative 5, 4, correct? Negative 5, negative 4, I think is what we got, right? We're adding because we're averaging. We know our original point was negative 8, 1. That comes from here, Alex. The point they gave us to start out with, this guy. Right. And now we're going to find the reflection. We know that this bit should equal this bit, and that should equal that. So we're going to write that. Negative 5 equals x plus a negative 8 is the same thing as what? Minus 8. Now we're here. Now we solve this problem. We're going to get x on its own. How do I get rid of the divide by 2? Multiply by 2. So I get negative 10 here. How do I get rid of the minus 8? Add it over. Turns out that A prime, the reflected point, has negative 2 for x. Now let's find the y part. I know that negative 4 should equal y plus 1 over 2, right? These bits equal each other. Times by 2 to get rid of the divide by 2, I get negative 8. Subtract 1, I get negative 9. That's A prime. How do you feel about that? Better?
Can I show you TikTok?
No. A prime is this point. Negative 2, negative 9. That's here. 1, 2, 3, 4, 5, 6, 7, 8, 9. A prime. There's the reflection. Our midpoint was here at negative 5, negative 4. What do you think?
I think I can do it on my own.
We'll see.
I think so.
We'll find out.
We don't have a lot of time.
We don't have a lot of time.
That's why I should do the TikTok.
No.
You have to.
Try this one with me.
Why does it I bet I can finish before you, Mr. Ray.
Probably. I have to teach it. What'd you say?
Peyton needs leg room. That's what he said.
Here's the original point. Here's the line of reflection. Original point is at 4, 6. That's A. Line of reflection has a y-intercept at negative 1 and down 3 over 2. There's the line of reflection, more or less. How do we feel about graphing the line of reflection?
Easy. 11. Squeeze it. Oh, I forgot to draw mine.
All right. After we get this done, what do we need to do? Yeah. Flip and negate to find our perpendicular line, right? So our line that's going to be perpendicular to that is going to be y equals, if we flip the slope, we get 2/3, right? Do we want it positive or negative?
Positive.
Positive, right? Because we're changing the sign. Go plug in your point and find b. All right, so we flipped and negated our slope.
What is y? Let's see. What is there?
Now we're going to find b. So we flipped and negated our slope, Alex, right? And now we're going to find b. We do that by plugging in our coordinate that they gave us. When we multiply by a fraction, we can either times by the top or divide by the bottom first. I'm going to multiply by the top first. What's 2 times 4? 8. Divide by 3? 8/3. So Alex, what I did is I multiplied 4 times 2. Got 8. Then divided by 3. 8/3. Xavier. You with me?
Yes.
Now you are. Subtract 8/3, right? So the question is, how many thirds are in 6? That way I can get common denominators. Well, how many thirds are in the number 1? 3/3, right? 3 over 3 is 1. How many thirds in the number 2? 6/3. How many thirds in the number 3? 9/3. Double that, we get 18/3. That's the same thing as 6, right? 18 divided by 3 is 6. What I did is I thought of 6 over 1, multiplied the bottom by 3 to get thirds, right? Multiplied the top by 3 to get 18. 18/3 minus 8/3 is 10/3, and that's b. So our line is y equals 2/3 x plus 10/3. We'll pause for station identification. Now we're going to graph that line. Good God, we're not going to graph it that way. What we're going to use is our original point that we know has to be on the line, and we're going to use our slope. What's our slope? What's our slope? 2/3. So we go up 2 over 3. We can also go down 2 over 3, and I'm going to keep doing that until I've got a nice dotted line that I can make. Does everybody feel good about graphing your line when the y-intercept is garbage? Use the slope and your original point. Is it going to work? I don't think it will. All right, there's our line. We need to figure out where they intersect, so we're going to set them equal to each other.
Let's see.
There's our line.
Oh, I thought you were like working on the bottom.
Nope, we're going to set them equal to each other now. So our original line was negative 3/2 x minus 1. And we know that should equal 2/3 x plus 10/3. I'm going to add 1 over to here. How many thirds are in 1? 3 thirds. So if I'm adding 3 thirds to 10 thirds, how many thirds do I get? 13 thirds. I'm going to move over the 2/3 x by subtraction. I'm going to write that out so we can solve that. And now I'm here. Again, how did I get 13 thirds? I said 1 is the same thing as 3 thirds. So when I add that to 10 thirds, 3 thirds and 10 thirds is 13 thirds. 3 thirds, 3 over 3 is still 1. Now we need common denominators here. I'm going to make these both 6s. How did I make the 2 a 6? times 3. So I multiply the top by 3. How did I make the 3 a 6? So I make the top times 2, which gets me a 4. How many 6 do I have now? Negative 13. I will see you guys tomorrow. We're going to do some more reflections for our review guide. And then we're going to go back and learn about vectors and translations to make sure we have that.
Let me show you my TikTok.
Make it quick.
It's pretty good.
Yeah, it's really good. I sent it to Alex. Zed sent it to me before, after. They all saw it.